In this video, I'm going to talk about how to use multiply and divide instructions. To deal with unsigned number, we use MUL for multiply, div for divide. For signed number, we use IMUL for multiplication, and use IDIV for division. We're going to check out the formats, how we can multiply. When we multiply two numbers, we have one number that's multiplicand, and another number will be multiplier. For example, suppose I want to use 16 multiplied by 3. That means 16 can be the multiplicand and 3 will be the multiplier. The multiplicand must be stored inside AL or AX or UAX. For the multiplier, you can use other same size register or a variable. Make sure it should be the same size. The product, the result will be inside AX if you use AL as the multiplicand. If you use AX, the result will be inside DX with AX. When we multiply, the number can grow very fast. So the result will be held inside a double size the original multiplicand and the multiplier. So if you want 25 times 100, you can put 25 inside AL, then multiply by 100. You can put 100 in a register or in a variable. Here we have example. 100H multiply 2000H and using 16-bit operands. In the data segment, there are two variables declared. Variable 1 is word size 2000H, or variable 2 word 100H. In the coding, and copy variable 1 inside AX, then multiply variable 2. So AX is holding 2000H. So AX is serving as the multiplicand, and the multiplier is variable 2. Since we use 16-bit operands, like we see here, when you use 16 bits, your result will be inside DX with AX. Okay. So the result is inside DX with AX. The result will be 2000 hundreds because we need to make 2100 times bigger. AX is 16 bits. 16 bits means 4 hexadecimal digits. So the first 40 here will be inside AX. The last 4 hexadecimal numbers 0020 will be inside DX. Carry flag will be set to 1. This is the rule how to set up a carry flag. The carry flag indicates whether or not the upper half of the product contains significant digits. Our DX is the upper half. DX is 0020. 2 is a significant digit, so we set the CF to be 1. Second example, 1, 2, 3, 4, 5 hexadecimal multiply 1000H. The result will be 1, 2, 3, 4, 5 and 3 zeros. And this is going to use 32-bit operands. So first copy the 1, 2, 3, 4, 5 into UX. So UX is going to be the multiplicand. Let's check out the format before we go on. So when you use UX, the multiplicand is UAX. You need to use same size multiplier and the EDX with UAX holding the product. Okay, let's check out the result. When we multiply this, put 3 zeros after 1, 2, 3, 4, 5, and this is the result. carry flag is 0. That means there's nothing inside the EDX. Let's check out. EDX is 32 bits, should be 8 hexadecimal digits. 1, 2, 3, 4, 5, 6, 7, 8. So the first 8 zeros are inside EDX. EDX has no significant digit, and CF is 0. So 1, 2, 3, 4, 5, 0, 0, 0 will be held totally inside EDX. So this is going to be the result. So EBX is the multiplier here, and EX is the multiplier. Here, this is one more. You can try this on yourself. You're trying to multiply 1, 2, 3, 4 each by 100 each. Then you move so BS is the multiplier, AS is the multiplicand. The result is 1, 2, 3, 4, 0, 0 each. The result is inside DX with AS because you're using 16 bits as multiplicand. And 3400 is the last 4 digits. Okay, let me put something here. The product is 1, 2, 3, 4, 0, 0, 0 each. So no, 2 there. I have extra 0. So let me put here. So AX is 4 hexadecimal digits, is 3400, and 1, 2 will go inside the DX. And the carry flag is 1 because DX has significant digits. And you can try this one on yourself. It's kind of similar. For signed integer multiplication, we use IMUL. Same kind of formats you can do, like we mentioned in the previous slide, this slide. So this still applies when you multiply signed numbers. Here we have example. Going to multiply decimal 48 by 4. So copy 48 into AL, then copy BL into with 4. So AL is the multiplicand and BL is the multiplier. The result should be inside AX. And 48 times 4, let me see how much, is 192. So when you multiply this is 192 and the AX is 00C0. This is hexadecimal and C is 12. 12 times 16, that should be 192. So this is hexadecimal format for their product. OF is 1, and let's see, OF is 1 because AH is not a sign extension of AL. Okay, let's check out the sign over here. Okay, let me make a note over here. Okay, I like to make a note here. Okay, it's not big enough. Let me put a note here, comments. AH is 00. That means 4 has, if we use a binary, it's going to be 8 binaries. And let's see how much is in AL. AL is going to be C0 or C0H. That's going to be C means 12. 12 means 1100. And then 10 means 40 in binary. So this is a C and this is 0. C0. Okay, I made a mistake. Let me undo. Okay, so the sign bit is the most significant bit in AL is 1, and AH if with sign extension should be 111 all over in these 8 locations, but it's not 1. So that's why we said AH is not a sign extension of this sign bit. So OF will be 1. Another example by I multiply. You multiply this number by this negative 423. This is multiplier, this is a multiplicand, and we use EX times EBX. The result should be inside EDX with UX. If the number is small enough, it's going to hold totally in UX. If it's not small enough, that means too big, it's going to overflow into EDX. And here, and we see the result is totally inside UAX, and EDX is just a sign extension of 8. The sign bit in 8 is 1, so FFF all means 1, 1, 1, 1, 1, 1. Okay, so OF here is 0 because your DEDX is a sign extension of UAX here. So you can try this one on yourself. Make this, the product will be 8760 with 2 zeros, and 600 will be inside AX, DX will be this, and DX is not a sign extension of this. The sign in 6, that means 0, 1, 1, 0, the sign is 0, so this should be 0, 0, 0 stuff, but it's not 0, so OF is 1. So that's about multiply. Thank you for watching.